Special theory of relativity put forward by Albert Einstein is based on two important postulates. Postulates are assumptions. So the first postulate is about the inertial frames of reference. So he said that the laws of physics are the same in all inertial frames of reference. So say for instance, if you have three inertial frames of reference here, one is F1 and F2, F3. And this is traveling at a speed v1, and this is v2, and this is zero speed. So frames of reference is basically a coordinate system from which you can measure the position or velocity of an object. And inertial frames of reference is a frame of reference that has to be at rest, or it has to travel or move at a constant speed, and it's not accelerating. So for instance, Earth, you can say it's a inertial frames of reference because it's orbiting at a constant speed. So the laws of physics are same in all the inertial frames of reference. That means that if you do a physics experiment in this one, F1, and do the same here and do the same here, so according to Einstein, it doesn't matter what speed you are traveling at, with what speed the inertial frame of reference is moving, the experiment should return the same results. For instance, if you are trying to validate the Newton's law, so you have applying a force to an object with a mass m in all these three inertial frames of reference, and you're applying a force F, and you're trying to measure the acceleration A. And you will find out that the acceleration is the same from all inertial frames of reference. So F2 might be a spaceship traveling close to the speed of light, and F3 is a stationary one on Earth, and F1 might be another one traveling at a different speed, and we're doing the same experiment in all three places, and they're all returning the same result. And you might do another experiment, something to do with electricity or thermodynamics within these three different inertial frames of reference, and you will get the same result. Just to remind you, Galileo, he also came up with this relativity theory, but according to him, he said that the laws of mechanics will be the same in all inertial frames of reference, but he didn't say the laws of physics. But according to Einstein, all the laws of physics are the same in all inertial frames of reference. And the second one is about the speed of light. So Einstein said the speed of light is constant in vacuum, and it doesn't depend on the motion of the observer or the motion of the source. If you're traveling on a train, this is a train, and there's another train going in parallel to the one that you are traveling on. So this is you, and this is your friend, and this is going at the speed, for instance, 200 kilometer per hour, and that one is going to 300 kilometer per hour. And if I ask you what is the speed of the train, so this is you and this is your friend, and if I ask you what's the speed of this one, this train, you would say in reference to your train, this is going at 100 kilometer per hour, because you will basically deduct that one from your speed, and you would say that's going on, you would say 100 kilometer per hour. I mean, this is a real world example. Like if that train is going at 200, you will see that train being stationary because it's not moving at all. If it's 200, and if it's 200, the difference is zero. And if we take the same example for another one where you are sitting this train, okay, and you are here, someone from here, the parallel to where you are traveling, is sending a laser beam this way. So laser beam is light and it travels at the speed of light, which is c. And now you're traveling, your train is traveling very high speed, not 200, 300. You're traveling at 0.5 c. It's a half the speed of light. So according to the previous example, when you look at the beam of light, how will you measure the speed of light? What will be like if you use the previous one? That means you would say the light speed from your train is going to be c minus 0.5 c, which is 0.5 c. Why? Because that's exactly you did here. Because here, this train is going at 300, you're going at 200, and you're saying the train is going at 100 because in relation to your train, it's going at 100. So if you apply the same thing here, you're going at 0.5 c, and the light beam is traveling at the speed of light, which is c. So you're going to see 0.5 c. But according to Einstein, this is incorrect because according to him, the speed of light is always c. Doesn't matter what your inertial frames of reference is, there could be another person sitting down here traveling at a different c, 0.6 c, and another person may be traveling opposite to this beam this way at say 0.7 c. They will all measure the speed of light as c. So this is Einstein's the second postulate, and based on that, he was able to explain time dilation, length contraction, and then we are talking about mass, which will increase. We call it relativistic mass, and then relativistic momentum. Momentum will increase. So he was able to explain everything based on these two postulates. The first one is the laws of physics are the same in all inertial frames of reference, which we explained in one, and then the speed of light is constant in vacuum, irrespective of the motion of the observer. So we have got many inertial frames of reference where people are measuring the speed of light when they are traveling at greater speeds, but the speed of light they will measure as c from all the inertial frames of reference.